G'day and welcome to another one of my videos. Today we're going to focus on sketching quadratic functions in the general form y equals ax squared plus bx plus c, and we're going to use the method of factorising in this video. In a later video we'll look at some other methods, but today we'll focus on factorising, so I hope you'll find it useful. So we've already seen how the dilation and the concavity of a parabola changes when we've got the equations just y equals ax squared. And we've also had a look at how we can shift the parabola up or down when we've got a quadratic in the form y equals x squared plus c. So this c value shifts it up and down. And we can also shift the parabola left or right when we've got it written in this form. So let's have a closer look. When sketching the quadratic equations, there are 5 main things we usually want to know. The first one is we look for the concavity of the parabola. So we're looking at this a value in front of the x squared, the coefficient of the x squared. And if that a value was a positive number, can be a fraction or a decimal or an integer, but as long as it's positive, then we have a concave up parabola. If the a value happens to be negative, then we have a concave down parabola. So one of my previous videos has gone through that. Then we also, one of the main important things is we want to find the y-intercept. And that's where the parabola cuts the y-axis. We can find that value by substituting in x equals 0 into this equation. So replacing the x with 0 and then solving that and finding our y value. And that tells us where the parabola cuts the y-axis. We can also find the x-intercepts. Now, sometimes there will be 2, sometimes there will only be 1, and sometimes there may not be any that exist. But to do so, to find out where it cuts the x-axis, we substitute in y equals 0 into the equation. So we replace the y with 0, so we have a quadratic equal to 0, and then we go and solve that. And today, as I said, we're going to use our factorising method. Another important thing we need to know is the coordinates of the vertex, so where the parabola turns around, and also the axis of symmetry is useful, sometimes called the axis. So the axis of symmetry can be quite useful when we are sketching our parabolas. And depending on which method we're using, sometimes we can do these the other way around. So the order is not that important, but it's important we do have these 5 things. So let's look at our first example. Our first one is we're going to look at y equals x squared minus 6x plus 9. We want to work out what that parabola looks like. So we're going to find our 5 things before we sketch it. Our first one is we're going to look at the concavity. So we're looking at the x squared, the coefficient of the x squared. And although there wasn't a number there, I've just placed it in there. If there's no number, it actually means that there's a 1 in there. So the coefficient of our x squared term is 1. So that's a positive value. So 1 is positive, which means our parabola is going to be concave up. So it's going to look something like this. We're going to have a concave up parabola. One way I like to say is if it's positive, it's a smiley. And if it's negative, it's going to be a frowny. So it's going to be the other way around. But in this case, it's positive. So we've got a concave up parabola. The second thing we want to know is the y-intercept. So we want to know where the parabola cuts the y-axis. So if it's shaped like this, it's going to cut the y-axis somewhere. So to do that, we need to substitute into this equation x equals 0. So wherever x is, we'll replace it with 0. So we're going to have y equals 0 squared minus 6 lots of 0 plus 9. And if you're not confident, you can use a calculator and you'll find that y equals 9. That's not a coincidence. That 9 value is also the same as that value there. Notice the whole lot I'm looking at, because if that was a negative sign, then that would be a negative 9 in there. But it's positive 9, so our y-intercept is positive 9. So we now know that the parabola cuts the y-axis at 9. The next thing is we'll have a look at trying to find the x-intercepts. To do that, we need to substitute in y equals 0 into the equation. So wherever the y is, replace it with 0, and what we're going to get is x squared minus 6x plus 9 equals 0. Now you'll notice that I've got my equals 0 on the end instead of at the front. It doesn't matter. Okay. Now that we've got that, I have a look at that and I see if I can try and factorize that. Now there's different methods we can use to factorising. You use the one that you're being shown and they're used to. I try and look for first having a look at the x squared. It's a coefficient of 1, so it's monic. So when it's monic, what I tend to say to myself is I want two numbers that multiply together to give positive 9, but add together to give negative 6. And when I do that, I find that we get it's a perfect square. We get negative 3 and negative 3, and we end up factorising like that. So you can practice your methods of factorising, and you should be able to get to these fairly quickly. Well, what does that actually mean? I now want to solve that. For what x values does it make this whole thing equal to 0? Well, the only way to square a number and get 0 is if what's inside here is 0. So what x value will make what's inside here 0? That will be when x is positive 3. So I get a solution of x equals 3. So since there's only one different answer, then the parabola touches the x-axis at 3. So it doesn't actually cross the x-axis, it only comes down and touches it. And with practice, you'll actually recognize that when we have perfect squares in there. So we've now got three things: concave up, where it cuts the y-axis, and where it touches the x-axis. What we now want to know is our axis of symmetry. So that's what I'm going to do next, to find my axis of symmetry. Well, you may know that this actually occurs when x equals minus b on 2a. Well, what does minus b on 2a actually mean? Well, it refers to these values up here. There is my b value, the coefficient of the x. There is my a value, which is the coefficient of the x squared. And you'll notice we don't need the c value. So my a value and my b value. So let's look over here. My a value, we said, was there's no number there. It's actually a 1. And my b value is negative 6. That negative belongs to that 6. So be careful with those. So just going through that, my a value is 1. And my b value is negative 6. Be careful with those negatives. So we substitute those a and b values into this rule. So negative 6 for my b value and 2 lots of my a value. And you can do that on your calculator if you're not so confident, and you'll find that x equals 3. Well, you'll notice that this happens to be the same as the x-intercept, okay, because they're both going to touch, or the parabola is going to come down and touch. So if it only touches the x-axis, then that must be where it turns around. So let's find our final part, the vertex. So we're going to substitute in the x value that we found over here for our axis. Okay, that's going to be our x value of the vertex. And we'll substitute that into the equation, back up into here. So we get y equals 3 squared minus 6 lots of 3 plus 9. And again, you can do that on your calculator and get y equals 0. So now that we've got that, the coordinates of our vertex, there's my x value and there's my y value. So write that down. There's a pair of coordinates. Okay? So make sure if you're asked to write down the coordinates of the vertex, you actually finish it and come up with the actual pair of, or ordered pair, or the set of coordinates. And now that we have all of those, we've got our 5 important things: what shape it looks like, where it cuts the y-axis, the x-axis, our axis of symmetry, and our vertex. So let's put all of that together. So let's sketch it on a Cartesian plane. We've got one here. At the moment, I've just put in my y-intercept. It cuts at 9. Let's go and put in our x-intercept, and now I've had to shift my axis a little bit. So we know that it cuts at x equals 3, or it touches at x equals 3. So it's coming from there, and it's coming down and touching here. So if it's coming from there down to here, and it's going to be of this shape, okay, then it looks like it's going to turn around somewhere. Now, because we've only got one value, it's going to turn around here, and we know that because our coordinates of the vertex means that's where it turns around. But let's put our axis in next. So when we put our axis in, remember it's an axis of symmetry. So this point over here, the y-intercept, we can actually reflect that about to get another point. And that's the beauty of parabolas being symmetrical. So I now know that it's going to come down here, touch that, and come back up there. Okay, so we've already got our coordinates of the vertex in there. The point 3, 0, I'll cross 3 up 0. And now we can complete our smooth curve, remember, coming down through here, turning around at our vertex and going back up through this other point. And there we go. So there we've got a sketch of our parabola. Okay. So let's look at a second example. Before I go through this second example, if I'm going too fast for you, remember, pause it, rewind it, fast forward it as much as you need to, just to make it easier for you. So let's look at our second example. Again, we've got a y equals 2x squared minus 6x plus 8. So we're in this form, in this general form here, and you can see straight away our a value is -2, our b value is -6, and our c value is 8, positive 8. So let's keep that in mind as we're working through it. So our 5 main things. Concavity. Well, let's look at our a value, because remember the concavity is the coefficient of the x squared. And just be very careful, because sometimes these equations are written in a different form. Sometimes the x squared might be at the end instead of at the beginning or somewhere in the middle. So just be careful. It's the coefficient of the x squared. So you may need to change the order in which the terms are written. So the coefficient is -2. Well, what does that mean? Well, because it's negative, the parabola is concave down. So it's going to be this type of shape. It's negative, so it's feeling sad, it's a frowny. So we're going to get that type of shape. So there's 1 point, 4 to go. The next bit is we want the y-intercept, where it cuts the y-axis. So if you recall, we substitute in x equals 0. On doing that, -2 lots of 0 squared minus 6 lots of 0 plus 8. Again, you can do that on your calculator. And we get y equals 8. Okay? That's that same value there, positive 8. Positive 8. So the parabola cuts the y-axis at 8. So the good thing about when the equations are written as y equals ax squared plus bx plus c, this c value here tells you the y-intercept. But be careful, it has to be written in that form. So some of my previous videos, we had some things that were slightly different. Okay, let's look for our x-intercepts, if there are any. If they're not, then it won't actually factorize. But let's go and have a look. We substitute in y equals 0. So now we get this whole function equal to 0. And I write the 0 on the right-hand side. And what I do notice when I'm going to factorize this is I should always look for common factors first. It does make things easier. And you'll notice that each of these have a factor of 2. In fact, what I'll probably do to make this positive is take out a common factor of -2. So we're using factorising. Take out a common factor of -2, and that becomes now x squared plus 3x, take away 4. So -2 times x squared is -2x squared. -2 times positive 3x is -6x, and -2 times -4 is positive 8. So please be careful with negative. Okay, we haven't finished our factorising because this doesn't help us yet, but we've now made this quadratic trinomial in here a monic one. So the method I use, now that it's monic, there's a 1 in front of the x squared, is I want two numbers that multiply together to give -4 and add together to give positive 3. Well, I find that I've got positive 4 and -1. Again, I'm not going into the nitty-gritty of the factorising, so I've just factorised it there. And now we want to solve that. So we've got three numbers multiplied together. Here's one number, here's another, and here's another number. Three numbers multiplied together to give 0, and that can only happen when one of them is 0. Well, that can't be. When can this be 0? Well, when x is -4, and when can this be 0? When x is positive 1. So my solutions there are x equals -4 and positive 1, make this quadratic and even this original one 0. So that now tells me that there are two different answers, so the parabola cuts the x-axis at -4 and positive 1. But remember, sometimes they won't factorise, which means we won't get any solutions, which means the parabola doesn't touch the x-axis at all. And we'll look at that in another video later on. So we've got three parts now. We now want our fourth part, our axis of symmetry. Remember, we can find our axis of symmetry using this rule, x equals -b over 2a. Remember our b value and our a value. So my b value happens to be, my a value happens to be -2, and my b value happens to be -6, remembering that negative belongs to the 6. And we substitute those in, and if you want, because it might look a little bit complicated to you, you can use your calculator, and you'll find that x equals -3 on 2, and that's the same as x equals -1/2. Okay, so before we go and find our vertex, we could use either of these. This is the correct answer, the most simplified answer, but when I'm substituting, I'm actually going to use this value because it's easier to substitute. Okay, so let's go and find the coordinates of the vertex. To do that, we're going to substitute our x value from our axis, which is this. I'm going to use -3 on 2 because it's easier to substitute in. However, you could change it to a decimal and use -1.5. That's easy to substitute in too. So let's substitute in our -3 on 2 into the original equation. So wherever the x is, I'm substituting in -3 on 2. You notice I've put it in brackets or grouping symbols, especially because of the squared. It's really important, otherwise we may get an incorrect answer and you might not know it. So we do that on the calculator if you feel more comfortable, and you find that the y value of the vertex is 12.5. So we haven't finished yet because we actually want the coordinates of the vertex. So let's write down our coordinates as an ordered pair, and we have -1.5 and 12.5. So we now have our 5 main parts. We can then come up with our sketch. So let's do our sketch. We know that it's going to be concave down, and what I've already put on here is we've put our y-intercept of 8, and we've actually put our two x-intercepts on here already, so -4 and +1. So we've done our first 3 steps, and knowing that they're going to go through these and also through that, we know that it's going to be concave down. Okay? But because it's symmetrical, we know that when x equals negative 1.5, right there, that it's going to be symmetrical about there. So let's put in our axis of symmetry, negative 1.5. And I'll just put in some grid lines there just to give you a little bit more of a look at what's actually going on. And so now we put all that together, and the important part here also is at minus 1.5, 12.5, which isn't quite on my diagram at the moment. I can fix that. And I've just changed the scale a little bit just to make it easier to produce the diagram. But you'll notice we've got negative 4, 1, cuts through at 8, goes up to 12.5, but that might not be able to read that because I've changed the scale a little bit. And we've got negative 1.5 here, which again I've changed the scale, so just be careful. But what I should do is, because I've got some odd values up there for our vertex, I will actually label what the coordinates of those vertex, the vertex is, because it makes it clearer and easier to see on the diagram rather than searching for all you're working out and so on to get there. So there's our 5 main things, and we've just learned how to sketch both a concave up and a concave down parabola by factorising. So what you really need to do now is to get a lot better and quicker at all of this. So you need to practice and practice again and practice again, and the more that you do so, excuse me, the easier it will become. So I hope you found this useful. Remember, rewind it, fast forward it, pause it, whatever you need to do to make it easier for you. But the important thing is for you to get quicker at it and more comfortable with it. So you need to practice it over and over and over again with different types of questions so that you get better. So I hope you found this video useful, and maybe you'll see and come and watch another one later on where we use a different method of the quadratic formula, and also by completing the square and how useful they can be. So thanks for watching.